Good evening, depending on where you are. I want to thank you for taking a portion of your day out to spend with us and kind of talk through how what we offer as you're potentially looking at NoSQL. As Baxter mentioned, I'm the director of the Developer Solutions Group here at Couchbase, where my team spends quite a bit of time trying to make sure that we have the right software on the client side, the right client interfaces to be able to interact with Couchbase Server. By way of background, though, prior to Couchbase Inc., I had worked mostly in the enterprise world, so worked quite a bit with the same kinds of large database systems that many of you probably have in your production environment. So I can certainly address a lot of those questions as well. So with that, I'm going to go ahead and jump into it. So if just to spend a moment or so on the history here, there's a good webinar, which is at couchbase.com/webinars from Dipti Borkar, a previous webinar in this same series, where she talks quite a bit about some of the history and what's different. And I'm not going to reiterate a lot of that, but I do want to raise a couple points about the difference between the RDBMS and what we're trying to service these days. If you think about it, especially these days, in the past, an RDBMS was mostly about managing a single server. Managing a NoSQL system, though, is very much about managing a cluster of systems. Like it or not, you're going to get into distributed computing. In some cases, especially if you've used an RDBMS in a sharded way or something like that, you've already seen some of those realities that you have to deal with as you start to move into this era of interactive web applications and needing to get responses very quickly. The other thing that I'd point out is that the RDBMS grew up in an era where most computer programs were actually disk-oriented. The reality of today is that people are looking for applications where they can get those very fast response times, where they're able to query and search data very, very quickly. And so you have demands, I'm sure, in your environments for those kinds of applications. And so NoSQL systems actually address, in many of those cases, the requirements for modern apps. And it's not to say that the RDBMS hasn't grown up with the capabilities of the systems and address the new application requirements. They've done a pretty good job, but there are certain fundamentals that make it very hard for the RDBMS to work around and still keep exactly the same programming model. So not necessarily their fault, just sort of the reality of the world that we're dealing with today. So keep that in mind as we walk through some of the rest of these, because you'll see why some of the choices we've made had been made. Just to spend a moment on the NoSQL landscape, and again, some of the previous webinars in this series cover this a little more specifically. There are a wide number of things under that NoSQL umbrella, so in this case, we're really going to focus on one particular area. You'll see get to that in just a moment, but just to be clear, under this NoSQL umbrella, there are certainly analytic systems, things like distributed MapReduce systems, the common one here, and a partner of ours is actually Cloudera, who have the Hadoop, which is typically used for large data analysis, more or less. It's also used in a number of other areas, but it's if you have a large amount of data and you're trying to make sense of it. We also have, in the area of online applications, there are a few different categories of NoSQL systems. There are key value stores, which are very simple and therefore very simple to get started with and use, because you just have the value of the data and the name associated with that particular piece of data, and the system will store it and retrieve it for you. It's worth noting that Couchbase Server actually works very well as a key value store as well as a document store, so we fit into both of those categories. I'll talk about document stores here in a moment. But also column stores. Column stores are mostly about grouping certain information together for purposes of a particular application. So you may have sets of records that are associated with one application, and they tend to work very well when you're doing things like message indexing and things of that nature. Can be used in certain kinds of online applications, but we would argue that in most cases, the easiest thing to build your interactive web application behind is a document store. Part of the reason we would make that argument is that we believe that that the kinds of applications people are building these days map very well that documents map very well to the entities in web applications. So you have things like a user session that maps pretty directly to a document. You could have a number of other things that are specific to the application environment, and those map very well to those documents. The other thing that we would argue is that JSON is just a natural data format for web applications, and I'll talk more about that in a bit as we discuss some of the opportunities in migration possibilities. So with that, let me switch here and talk just a couple minutes about what's different as you start to look into a NoSQL system. So this webinar is mostly focused on people who may have had some exposure to a NoSQL system, but are sort of still trying to understand what would be different for me as I come from an RDBMS. So in the case of Couchbase as a document database, the big difference is that you'd notice right away is that that you have a few possibilities that you didn't have necessarily before. In the world of an RDBMS, you frequently spend a lot of time with developers on schema, and that's different in the case of Couchbase. I'll talk more about that in a second. You'll also notice that the programming model actually matches very much the way the data model works. There are some querying differences. This is a big area of conversation, and we'll give an introduction into some of the querying differences here. And then there are frequently questions about how do I do certain things with transactions in this world of Couchbase as a document database. So let's talk for a moment about schema and schema updates. Sometimes you'll hear the term, you'll occasionally hear somebody refer to NoSQL as being schema-less. In the case of document databases, that's actually not really accurate. It's more that there is a schema, but the schema is implicit to the documents. So each document has an implicit schema associated with it, and that schema is generally created by the application developer or by whomever is working out what are the appropriate attributes on that entity. But it can be done in a very flexible way at the time of creating the application. You do not necessarily have the requirements, whether they're useful to you or not, of breaking down an individual record or set of records into a particular normal form to store it in the database. In this case, what you see on the screen here is a receipt. And a receipt is a real-world type of document. I'm borrowing this example, I think, from my colleague Benjamin Young. And you can pretty easily extract a schema just by looking at that document. For example, it does have a date. Each receipt would typically have a date, time associated with it. It might be represented in a couple different formats, but it'll be there. It'll have the items that were purchased, and then it will have an amount that was paid, for example. And so there is a schema here, and then there's extraneous data. There's information about where it was, etc. But I just want to point out that even in the simplest example, even just a document database that has a single document, there is a schema. As I add more documents to that, I can use that schema information across those documents and extract different information, and even query across that data in different ways. So assume that my company is selling burritos, and we're keeping track of what we're selling for whatever reason, and all that's going into my document database. And suddenly marketing comes along and says, we've done some research, and it turns out we're going to be really big in Japan if we can go open up a store in Japan. So the business says, we need to go do that. Let's create whatever we need to, open up the store there, and I want the IT systems, I want the databases that we're using to be extended to be able to support what's going to what comes out of our Japan growth market. So in that case, I now have another receipt. Now, this document also may not have exactly the same format as the previous document, and I don't even actually have to worry about that. It's kind of nice in that a document-oriented database allows me to normalize and extract information from the document at the time that I'm querying it, or really at the time that I'm indexing it. So this document is another receipt. It too has a date. Now the date is represented differently here, so I may need to do some normalization when I go to query it. It too has a set of items. In the case of the items, now the representation, even the string, the character set in use is potentially very different. But even if, for whatever reason, my old version of the application only wrote data in, say, the Latin 1 character set, and this new one has UTF-8 that's going into the database, that's perfectly acceptable. So I can extend this to these new document types with simple application changes and not have to worry about making a big schema modification. I still have values. So two different documents, but each one has an implicit schema, and there's certainly common elements to them. And then we use those in Couchbase to be able to extract information for the purposes of query. We'll talk a little more about that in a bit. Again, if you have any questions, feel free to go ahead and type them in, and then I'm going to pause here in a little bit and I can address any questions that come up. So where are the advantages here? Well, one advantage that we'd mentioned a little bit was that because the schema update is required to support my new Japanese market, I am able to update that schema very quickly and easily without having to bother or touch the previous data. Just to relay a brief story, I think it was from the MySQL conference a couple years ago. There was a situation where a Facebook engineer relayed desire to add a new feature to an application, and so that meant for them to add that column to their set of databases, whatever database it was in use at the time. To add that column, it was going to be something like an 8-month effort, and that meant that they had to come up with a different approach for being able to where to put the information for that feature. In the case of document databases, it's actually relatively straightforward for us to add new features, add new attributes to existing entities as required, or in our case, documents. So all we would need to do is add potentially the different fields to the new documents, and then we obviously those are going to come with an application level upgrade. Now, what do you do in the case where there isn't a sane default for this new field, or where I retrieve an old version of the record and that doesn't exist? Usually what we do is at the application layer, there's a pretty obvious default for what to do. An example might be adding loyalty points to the receipt. Maybe I introduce a loyalty program. I'm now tracking how many burritos people are buying. I'm going to, if I pull up an old receipt for some reason, I know this is a little bit of a contrived example, but if I pull up a receipt for some reason and I want to extract the number of loyalty points earned off of that old receipt, if it's before the loyalty program, then I can default that very easily to 0 points. We may need to, when we're developing the schema for these documents, or when we're storing these documents, you will notice, though, that we sometimes incorporate fields to assist with processing those documents. An example is we'll frequently have something like a doc type field, or sometimes you'll see a type field in a document that identifies, this is really just specific to your application, but it identifies the type of document within the overall database. The reason for that is that you often use that as you're doing different control processing when you're creating views across documents, and I'll talk more about that in just a bit. The other thing worth mentioning is that you sometimes will add fields for handling upgrades to versions of a document, or even to, in some cases, remember previous states of what had happened with a particular entity. So those are more advanced topics, and we won't necessarily address them here, but I did want to just mention that these are a few techniques as it relates to creating documents in their implicit schema. So moving forward, talking just a little bit about the programming model and the data model. So one other difference as you start looking at a NoSQL database is that you'll find that the data maps much more naturally to the data store. The big advantage here is that developers can end up spending a lot more time on the application at hand than the mapping logic. Even in this world of very modern object relational mappers and so forth, there can be situations where developers are spending a lot of time thinking through migrating data or dynamic migration of data, which is actually a little bit more of a challenge than is really required with modern systems. We're sort of doing that mostly because we're designed around systems that we're trying to minimize I/O and trying to make sure that they were keeping certain constraints in place that maybe we handle more at an application level. One good example of this is the use of ORMs for handling the impedance mismatch between what the application developer is doing and what the document database is doing. I'm sure many of you have heard the term impedance mismatch before as it relates to database development, and especially in the context of NoSQL. But to give a little more detail there, if you think about it, the relational database grew up mostly in the 1970s and 1980s based on a number of the same concepts that had existed in the 1960s, breaking data down into tabular format, going through an amount of normalization to make sure that we have pretty well structured data. Most application developers these days are using object-oriented or related to object-oriented programming languages. And object-oriented programming languages tend to represent entities in memory and in the program really as an object graph. And so we have a set of software that lives in between these two. We call them ORMs, object relational mappers, and there are a set of them for different languages. And these things actually do a really, really good job. They're spending a fair amount of time taking that object graph that the developer has assembled in their head for the application, and then they're translating that to the relational structure and relational algebra that the RDBMS provides you. That said, there are still certain challenges. Frequently, these things create certain challenges for the DBA or even for development process. So is the DBA responsible for coming up with the appropriate data model or should the developers do that, or should the developers just allow the ORM tools to do that directly, and then the DBA has to sort of get engaged to work out how they're going to optimize that. So it's a real issue, and it's in some cases an issue that we don't necessarily need to deal with if we start representing data a little differently, and the capabilities of modern systems really allow us to do that pretty well. So that's one difference that you'll notice, is that programming model and the data model match much more naturally. The way a couple colleagues say it is that document-oriented databases really match the world around you pretty well. You can look at almost anything and come up with a series of key values or hierarchical structure in a document to represent pretty much any entity in the world around you. Another difference, and this is getting maybe a little more to the meat of differences, is that a document-oriented database versus an RDBMS handles querying and joins in a bit of a different way. So I'm going to stay pretty high-level conceptual here, but I'm happy to get to further low-level. If you have any questions, please go ahead and enter them in. But the main idea here is that queries in Couchbase are achieved with something called Couchbase views. Now, views are actually just really simple pieces of MapReduce logic that are incrementally run as documents are mutated or added. And before you run away screaming, thinking, oh, he said MapReduce, this means that there's a lot of complex logic and I got to get a programmer involved to be able to make sense of it. Reality of the views that we frequently run is that they're actually quite simple. They're usually just extracting a couple entities, or I'm sorry, attributes from the document and putting those into the view so that we can query across that view at runtime by any of the given SDKs. The thing I'd want to point out here is if you've heard the term MapReduce before, chances are most people have heard that term in context with something like Hadoop MapReduce, which is really about building chains of MapReduce tasks to extract data from very unstructured data. In the case of a document-oriented database, we have the documents, as already pointed out, have some sort of structure already. And the power of Couchbase is that we actually incrementally run that as documents are mutated or added to the system. So that means that every time you're modifying a record or adding a new record to the system, we will run the map and reduce against that document, or even re-reduce it as required when you're querying the system. So it makes for a very simple and very powerful way to use this sort of logic in a system designed for interactive web applications. We don't have to run it across the entire system, for example. Now, those views are composed in JavaScript, and that maps pretty naturally to JSON, which is the data format that we use in Couchbase Server. Although I should also point out that we'll store binary blobs as well, but in order to really get a lot of the most useful querying and join information, to be able to do joins across documents in Couchbase, you'll typically want that to be a JSON document. And the beauty of this is that these are actually rather powerful in that you can normalize the data at the time of building the index. So thinking back to the receipts earlier, you may have noticed that one particular type of receipt stored the date with year, month, day. The other one stored it with month, day, year. That's the way we do it in the US, which is a little different than most of the world. And rather than forcing all of those to be normalized at the time of storing it into the database, we can actually normalize it at the time of building the index. So we can work our way through those documents and even do transformations or run other logic when we're building that index. And as software developers start to develop against this system, they actually find it pretty powerful to be able to do things like that instead of having to define other logic or try to keep everything very structured and normalized. So let's look at one example of how you might actually do a join with a document-oriented database. One possibility is that you can use you can actually do the join itself at the application level. So in this case, I'm showing a structure, if you will, and a graph of documents. I have a blog itself, and so that blog may have a set of comments associated with it. Each comment may actually have a reply to that comment associated with it. So there are situations maybe where I want to just retrieve the blog and not the comments, or I want to retrieve the blog and a certain number of the comments, but not all of them. And maybe I have situations where I want to show the expanded set of comments or not. So in this case, the application is actually very much in control. So it'll retrieve the blog first, then it will retrieve the list, then it will retrieve the first comment, or as many comments are required for the logic, and then it may retrieve any replies. Now you might be looking at this saying, wait, you mean I got to do 1, 2, 3, 4, 5, 6, whatever number of operations are required in order to show the data? And yeah, that is actually accurate. However, we're also talking about a system that frequently services requests in under a millisecond, and so that we're really talking about being able to retrieve that data on the order of just a handful of milliseconds. And Couchbase Server does that all the time. I'll talk a little more about how we do that later. But the main point is that versus having to create, say, in an RDBMS, an MVCC context, have it do the join and then return a large chunk of data. We can actually just do joins at the application level. One advantage to this is that we only fetch the data when we need it. A good example of this might be if you've ever been on, say, a social networking site, just a Facebook as an example. Maybe what you're seeing is on a person's profile, it's not a blog, but it's a set of wall postings, and you're seeing the certain number of wall postings at first. And as you scroll down, further down in the page, the application on the server side, or even from the client that now has some sort of representation of what needs to be requested at the server side, will only fetch the new data as required. So as you scroll down that page, you'll notice that you continue to see more and more entries, and you can go further and further back into the past. The page didn't actually show it when it may have shown initially just the blog and the first 3 or 4 comments, because that's all that was required to fill the screen at the time. But as you scroll further down, maybe you want to be able to see more of the information there. The other advantage here is that we can spread the data and the load across the entire cluster. So this blog, the list, and the comments and the replies to comments they're going to automatically be sharded across all the nodes of the cluster. So I didn't have to actually worry about how am I going to be able to get that information together. And frequently we just do this with conventions around keys and lists. I would actually encourage you to look at our blog.couchbase.com, funnily enough, to see there are a series of blogs there from a guy in my team named Benjamin Young. Benjamin has a couple of good blogs on how to break down how to model data for a document-oriented database. Now, having said all of that, there are still situations where Couchbase, you may want it to handle doing the join for you and handle doing the querying for you. So this is actually an example borrowed from Bradley Holt, who's a community contributor. Bradley did a presentation at Couchbase, CouchConf Boston not so long ago. And the presentation is very, very good. I'd highly recommend, if you get a chance to go pull up the presentation, please do. But the main point here is that when we're constructing the view, we can do joins across that data as well. So what you're seeing in this example is that on the joined result set, this is an example of what you might do with an RDBMS. If I have a joined result set, it's going to have the publisher ID and publisher name and a couple of columns from the result set of the join, and then it's going to have the book in a book.title from that joined result set. In the case of a document database, document-oriented NoSQL database, even though this data is distributed across the cluster, Couchbase Server will handle putting the view together for you automatically, either through the SDK or any other RESTful queries to the view engine. And what you see here is that we're leveraging a technique where we do collation of that result set. So now when that application, rather than the application walking its way through that tabular data structure, it can issue the kind of query against a document-oriented database where it knows the first record is going to be the publisher, and then every record after that is going to be the books associated with that publisher. The way we've done this is with a compound key in the result. So I know this is probably a lot to understand, but just to give a flavor for it, because everything's sorted by this first key, and through a convention of just emitting from the MapReduce, when I build the view, I can say if it's a book, if it's a publisher, emit the publisher name and the numeric 0, numeric value 0, and if it's a book, emit the publisher name and the numeric value 1. So then when I go to query the system, I can query very easily for everything from a given publisher and be able to see all of the books associated with that publisher. So this is a way of doing a collated result set within a document-oriented database. We could even extend this a little further, make our compound key a little longer. Say, for example, we want to sort those by author last name. If we were to include here in the emitted results set, or emitted results from the view, the author's last name, then we would have those books all sorted by last name, or we could have a view that sorts it by book title. And that's actually pretty powerful, because now we're able to go directly to that in the view, and because it's a view specifically for the kinds of query I'm doing, it's very, very fast and very easy to use from a programming perspective. One other question that frequently comes up when people start looking at document-oriented databases, NoSQL type systems, is how do you handle transactions? Well, before we talk about the transactions, let's think about what transactions actually provide. So the main thing that people are looking for with transactions, and different RDBMSs handle this in different ways. The most common one is an MVCC, creating an MVCC context. But unfortunately, that becomes very hard to scale across multiple systems. So frequently, we end up having to trade that off in order to be able to scale the system reasonably. So in the case of a document-oriented database, the changes to a given document are always atomic. The Couchbase is always consistent. So a Couchbase server will always return whatever the current version is of a document. That's by design. We want to be consistent, not eventually consistent, because that makes the system easier to program. And changes to that document are always handled in order by the database server. And so this actually allows us to provide the most common cases, situations where you're actually modifying different attributes of a given entity, because now I have those pulled into a single document instead of spread across multiple tables. So I can modify multiple attributes, and then I still do that atomically and with consistency on the system. Now, and that actually gives me a lot lower overhead versus what I might be doing if, say, that ORM is going off to different entities out in that RDBMS. Now, there are some alternatives out there in the NoSQL world. There are systems that provide eventual consistency. Couchbase is not one of them. Again, in the case of just trying to focus on these interactive web applications, we believe that it makes sense to try to maintain consistency rather than go to an eventually consistent system. And the main reason we believe that's the case is that being eventually consistent actually brings, for many applications, a higher burden for app development. I know this is potentially a lot of technical terms, but in the case of maybe an eventually consistent system, that means anytime I ask, there's always the possibility that I can ask the database for a given record and get 2 replies, and the database can't actually tell me at a given moment which one is currently valid, because it's working its way to eventual consistency. So I can certainly talk more about that if anyone has questions later, but just wanted to mention that that's one thing that you can do in the case of Couchbase. Now, you might be looking at that and say, well, that's great, but I'll still run into situations where I need to update maybe multiple documents at the same time. And yes, that is true, but when needed, certain kinds of transactions can actually be modeled at the application layer. And actually, if you think about it, this is something that we end up doing regularly between many different systems, where maybe it's 2 different databases, or it's even just 2 applications that are communicating over RESTful web services or something like that. One example of this that you see there on the right-hand side would be a 2-phase commit to provide logical atomicity across changes to multiple documents. The application is actually, in this case, creating a new document, an ephemeral document for a period of time that's associated with the transaction, and it's manipulating attributes in each document. And you do see that that is 5 steps, so that means 5 different operations within the system to achieve this atomic change across the multiple documents. But this is really about the only way to do it on a distributed system. And we do want to have a distributed system so we can make it fast and we can continue to make that system scale. We're not forced to try to pull everything into one system and have it handle locking. The other part of the reason it's fast is because not every operation has the overhead of an MVCC context, which in the case of a relational database, every single modification, typically people say, for example, with MySQL, have auto commit turned on, and so each individual operation, if you're using, say, an InnoDB backend for that MySQL, it has an MVCC context associated with each individual request, and there is overhead to that because the overhead is there. It does have an impact on the performance of the system, and you know. RDBMS do a pretty good job of handling caching and so forth associated with that, but because of some of the design decisions in Couchbase, we're able to go even that much faster when we're working with the system. So let me pause here for a minute and see if anyone has any questions. By all means, please enter them into the chat here or into the Q&A panel, and I'd be happy to answer them. And if not, I will just continue on with the presentation. Okay, great. So in terms of new projects and what are the right kinds of opportunities for a document-oriented database if you're looking to migrate or looking to use Couchbase. So what we would argue is that you frequently want to seek project opportunities to try where you have potentially data models of moderate complexity. They could even be high complexity. It'll just, you know, it'll put more burden on your thinking. I don't want to say that a document-oriented database can't handle high complexity. It's just going to be easier for you initially if it's of moderate complexity. And the nice thing is that you can start where, especially where maybe the entities behind that that application are not necessarily well understood. So this is where the flexible schema becomes a really interesting aspect to things. You're able to handle the fact that as you're developing this new application, you're able to handle the fact that that this is part of that the flexible schema gives this benefit to you. Sorry, I'm tripping here a little bit. A question came in, so let me go ahead and jump in and answer that. So the question is from are all of these features in the 2.0 rollout, and is there an estimate for that? So the answer is yes. All of these features, everything I'm talking about here is in 2.0, and the 2.0 is currently in developer preview for those who aren't aware, and we expect to be able to ship a version of 2.0 probably in Q3 of this year. So I know it's taken us a little while to get 2.0 pulled together, but you've seen, if you've been tracking its development, we've been very quickly responding to what people have wanted to see in 2.0 and addressing some of the questions about how to use it. And there are recent builds shipping on a regular basis right now. So all of those are on couchbase.com/download or downloads all. So getting back to the question about the slide at hand, opportunities. The other place to look for projects is, seek opportunities, seek projects where they benefit from that sort of easy scaling or built-in high availability. In other webinars, we've covered how you can scale a Couchbase cluster. It's really just a matter of installing another, getting another server or VM, pointing it to the existing cluster and rebalancing. You don't need to do any application level changes. You don't need to deal with sharding at the application level. So it's very, very easy to scale and have that kind of high availability with the system. It's also useful to look for projects where the data is stored in, where the fact that the data is stored in a heterogeneous JSON format benefits interoperability between multiple systems. What I mean by that is we have a number of deployments and customers where people are, say, using Java and .NET in the same system, and it's easy to, in each of those languages, to deal with JSON data and extract that back into an object-oriented representation of the same JSON data. And so that kind of interoperability is pretty good. You can actually describe exactly the same entities rather than having to you know, rebuild those entities in each different programming language and teach the ORM how to map them down to the system. There are actually really good high-level language features in, say, the case of Google's JSON, and .NET has an equivalent library that handles mapping of JSON. Pretty much every programming language on the planet. So that's what's really good about JSON, is it's a very heterogeneous format. It's also good to seek project opportunities where the JSON data may be used directly in either the web console or the oops, apologize there. Let's get back to this. It's also good to seek opportunities where you'll get where you may actually want to use the JSON data directly in the web application or in a mobile app. So in some cases, that means that the server-side logic really isn't doing much other than passing that data directly down to the application. So let's talk a little bit about migration of existing applications. So in existing applications, what should you look for? Say all this Couchbase stuff sounds good to you and you're looking for an opportunity to try it out. What kinds of applications are good to try?
Hey
Well,
Matt, this is Baxter. Sorry to jump in here, but it looks like we're having some issues in seeing your screen right now.
let's see what we can do to solve that. Apologies for the problem here. Do you see the screen now?
Yes.
Okay, great. From that, okay. Sorry for the trouble, folks. So talking about application apps that might be good to migrate. Baxter, everything, let me know if you're having any trouble seeing things.
No, it looks
But
great.
the apps, okay, great. Apps that are good candidates to work with are apps that are maybe at that right stage in their life cycle. So a good example of this is an app that needs new features, and maybe those features were not incorporated in previous version of the application because of the overhead associated with development or the overhead associated with the with storing the data and scaling that data. Another example, and this is what I'm showing sort of in the chart there on the right, is we've definitely seen a number of times where people are deploying applications, users of Couchbase are really moving to Couchbase to get onto that next growth curve. For example, I know we've been working quite a bit with Orbitz and a number of other customers, and they just need to be able to introduce new features that they expect are going to bring in new users and new demands on the system. And so they need to look to migrate to something like Couchbase Server to be able to handle that growth curve. The other place to look for is, other thing to look for is applications that are under pressure, maybe at something like the session store growth. There have been a number of situations where just something as simple as migrating the session store from a file-based system or an RDBMS-based system to Couchbase, which has built-in high availability, built-in replication, makes it very, very simple to continue to scale that application, take some of the pressure off of that RDBMS. And as already previously mentioned, handling situations where features have been held back because of development time or RDBMS inflexibility. So let's talk just a moment or two about techniques for migrating. So when you're migrating the RDBMS, we actually find that the easiest way to do things is to, where possible, introduce the new system meaning the new version of the application that's using Couchbase alongside the current system, shifting appropriate data over to the new system as you go through the life cycle of the application and develop new features for it. This makes for the easiest way to get information over to Couchbase, since you can just simply retrieve the data from Couchbase and bring it into the new system as required. So it's also good to look for another good migration approach is to convert data as needed using the RDBMS as a read-only migration store. So we've definitely worked with a number of deployments and users in situations where they just effectively, in a new version of the application, when they try to get the data from Couchbase and it's not there, they go and pull the appropriate data from the RDBMS and store it into Couchbase for going forward. Both of these techniques work very, very well when there's a clear data access layer in the application, and it's easy to modify that data access layer to handle the situation. So most well-written applications are going to be in that state, so it should be pretty straightforward. Now, it is also possible, though, say for whatever reason you want to make a clean break, you can go through a process of first building migration utilities, understanding what the new document representation of the database is going to be, and with those migration utilities, you can work out how to go from your RDBMS to the new version of the application that accesses things in a document-oriented way in Couchbase and takes advantage of all that built-in replication, high availability, and ability to scale out. So I'd encourage you to go have a look at couchbase.com/case studies for some more information on that. Again, I know at CouchConf San Francisco, we're going to have a few presentations from folks who have done this sort of thing, and that should be pretty good for you to hear as well. Some common questions as you're looking at migrating. So you're very used to your existing database. You know how to manage all of those, and it has a lot of controls that you've had over the course of time, or that have been added to the RDBMS over the course of time. So you want to sort of understand, if I go to Couchbase Server, how am I going to be able to do these same sorts of things? So just to address these relatively quickly, so, will you have the same resource controls maybe around memory resource controls? Well, yes, generally speaking. So Couchbase Server has excellent control of memory resources on a per bucket basis. I'll talk a little bit about that in a second. But disk is technically not actually controlled, but that's often not a problem. For those who are familiar with Couchbase Server 1.8, you might be familiar with the fact that sometimes you need to clean up, effectively vacuum the database, if you will, on a regular basis with 2.0. And by the way, that's common with NoDB and other database systems out there. Couchbase Server 2.0 actually introduces auto compaction. So without getting into huge technical details, just to mention it briefly, Couchbase uses an append-only file format, which basically trades space for time, so it's faster, but creates larger files on disk, and at some point you have to clean those up. Usually that's the right trade-off with the way modern computer systems work. We usually don't have a disk capacity problem, we have a disk I/O throughput problem. And so in the case of Couchbase Server 2.0, we do that very well and have a really good way of controlling auto compaction within the server. So you can define times of day that you maybe don't want to compact, etc. Another question that comes up is, will I have multi-tenancy? Will I be able to have multiple applications or multiple groups use that same cluster? The answer is yes. So we have a concept called buckets in Couchbase Server. Buckets are kind of analogous to databases, if you will, and an RDBMS that's managing multiple databases. And we do have SASL authentication in each one of those. You may also ask how you can manage the indexes in the system, how they're built, when they're built, what they're made of. And the answer is yes, definitely. So both at application use time, meaning that the SDKs, or through the Couchbase Web Console, we have a pretty good workflow for being able to define and use those indexes. As a matter of fact, I would argue that we do some things that are pretty unique and pretty useful. You can imagine that there are scenarios where you want to building an index can be painful, if you will, across a very large relational database system. We actually have a way of creating development time views that just operate against a subset of the data, which is really, really useful when you're developing a set of new views against an existing data set. You don't take the performance hit of needing to walk across that entire data set or create the index across that entire data set. You can just use a development time subset of it. And I defer you to the documentation to get more on that. What monitoring is available in the case of Couchbase? There's built-in monitoring in a with a RESTful interface demonstrated, and we've demonstrated integration with other tools like Nagios externally. So pretty good built-in. The last webinar by J. Chris Anderson actually talked a little bit about what's available in the web console, so I'd encourage you to go back and look at that webinar if you haven't seen that already. A couple other common questions. One is that how can I back up and restore the system? Couchbase provides backup and restore tools that allow for the creation of backup files, and you can actually restore those files while online. Now, these actually back up to disk, not necessarily to tape, but there are good ways in lots of systems to be able to manage that. And a pretty common case if people are deploying to cloud environments, just to use an example like an Amazon EC2, is that they'll put those backups on S3 and come up with an appropriate retention period. Another question that may come up is how can I prepare for disaster recovery? This is actually a pretty neat one. So Couchbase Server 2.0 will introduce a feature for cross data center replication. And with cross data center replication, we'll have the ability to replicate to an online cluster, potentially another data center. So imagine that my primary data center has 20 or 30 nodes, and I just want to make sure I have a copy of all of that data. I'm not actually querying it, or I don't have a lot of operations, if any, occurring. I just want to have a copy of that data. That cluster could, that 20 or 30 node cluster could replicate, say, to a 3-node cluster, just to make sure I have some redundancy in an alternate data center. And Couchbase Server 2.0 will deliver that feature. There's a question here, so let me jump in and address it. The question was, is there a PHP or C client built for Windows, and are there any plans here? The answer is yes. So the libcouchbase, that's directly as part of my team. Libcouchbase is the C client library that's used at the low level, and then we built a PHP extension on top of that. And I'm very happy to say that we worked with Pierre Joy, who's the primary guy in the PHP world who looks after a lot of the Windows extension development, and we made sure that libcouchbase would be portable to Windows. So the plans are definitely there, and at this stage it's really just a matter of finishing up a couple final details and doing some testing. If you would like to get in contact with us directly, I'd be happy to actually try to send you a preview release of that and get your feedback on it. So with that, I want to conclude before we're out of time. I do want to actually invite you to a couple different actions. One is to join us if you're interested. We are actually hiring. If you or somebody you know is looking for an opportunity to get into this fast-paced new world of NoSQL, I guess, for lack of a better term, please check out couchbase.com/careers. The other thing that I'd say is please join the community. Download, develop, try it on your next project. I didn't necessarily mention it here, but we should. The Couchbase server is actually Apache 2.0 license, so it's open source, and we do a lot of work in the community. We ship things ahead of when we're ready to ship them as a GA product, and that's in part to get feedback from people and make sure that we have the ability to incorporate those into the product. Feel free to get in touch with us on the Couchbase.com forums. Questions like the PHP client library question are perfectly appropriate for that, or you can tweet to us at Couchbase, and I can be reached as Matt at Couchbase.com or at Ingenther, which is the first 8 letters of my last name. So it makes me relatively unique out there on Twitter. And so with that, I want to say thank you very much and see if there are any questions. So again, if you have questions, please post them in on the GoToWebinar control panel. That can either be through the question panel or the chat panel. I'd be happy to answer them. Another question is, do many of those techniques apply to the shipping Couchbase Server 1.8 already? And the answer is yes. So actually, the join techniques, while we don't have views in 1.8, a lot of the join techniques work as well in Couchbase Server 1.8. For example, that's how existing companies such as Zynga and use with both some of their classic games, and OMG Pop had used with their Draw Something when they scaled that. So that doesn't actually use Couchbase Server 2.0. It's really using Couchbase Server 1.8. There's an upcoming white paper that we plan to publish on how to do some data modeling, but I'd also still refer you to Benjamin Young's blogs that you'll find at blog.couchbase.com. Any other questions? No? Well, with that, I want to thank you again very much for attending. I hope it's been useful. And please make sure you take a moment to fill out the survey. Let me know how we've done. And we will post both the slides and a replay of the presentation later. And get in touch if you have any other questions.